Hello, I'm Matthew Ong, the advisory specialist for NCM Self Service. Today, I'm very happy to have Abhishek, who will be joining in our call. He is actually our staff engineer from the NCM Self Service R&D team. Today, we are going to show you how we can get NCM Self Service to work together hand in hand with Terraform providers. Let's look at the agenda today. The first agenda, I'm going to talk about how Terraform and NCM Self Service, or formerly CAM, can work hand in hand together. Next, we're going to talk about the 4 use cases that developers or DevOps engineers will commonly use. The first use case is to provision a single VM. The second use case is to perform a day 2 operations to stop the virtual machine. The third use case, Abhishek will show you that how we can use the Terraform providers to provision a multi-VM blueprint. And the last use case is how we can actually clean up the resources. On the right side of the ecosystem, right, you can see that all these are the Nutanix ecosystem. So there are VMs, there are databases, there are Kubernetes clusters, and there are storage, right, that are being provisioned through the NCM Self Service or the CAM blueprint. So our customers primarily can request for all these resources through the marketplace. With the advancement of DevOps, so we do have customers coming from the developers or from the DevOps side, right? They prefer to use another software such as Terraform, right, to interact together with NCM Self Service. The first use case is for Abhishek to demonstrate how a single VM blueprint can be triggered from the Terraform providers. Abhishek, over to you.
Yeah, thank you so much, Matthew. So let's go ahead and see how our blueprint will look like. Then we will see how we can create our Terraform configuration file where we can put which details are required to provision a blueprint. So let's go with a single VM application. This is our BP. So this the VM details, and these are the VM configuration where we can define the CPU, the ports which the user wants to provision it. We have attached text and attached NIC. So this is our simple blueprint case for the single VM. Now we'll look at the main DF file where we can see that to provision a blueprint, we just need a blueprint name. And the required fields are application name and app description. App description is an optional. So to provision a single VM, a BP, we will be just needing a application name and the BP which we want to launch. So we will go ahead at our console and we will see if we will do Terraform plan. We will be able to see that it's saying that we want to create a one resource with this particular application name and the application description. So let's say we'll go ahead and say Terraform apply. And we will say yes. So I will just switch it over to applications page. Yep. So we can see that application is being started provision on our PC side. And we can see the audit section where we can see the multiple steps, how substrate are getting created. And then we can see the overall the status of an application in UI that we have called from our Terraform plugin.
The provisioning is going to take about 1 to 2 minutes. I believe that the provisioning is going to complete really soon.
Yes, it's completed. Let's see the steps. Application is being provisioned. But the IP, okay, service packages are getting installed. It's like, oh yes, so it's into a running state. Now we will see our Terraform will declare that the app is gone into a resource have been created. Yeah, so it says that our resource has been created and we can see the VM info which is coming here. So now what I will do, I will walk you over through the how our TF state file will look like. So these are the actions. So what we have given as an output to the user, that these actions will show all the actions which are present in the application. So if we go here, manage, we see the actions here. Similarly, we have listed all the actions where where an app can perform. Then we have an app summary, which tells us which project we are going to use, what's the application UID, what's the application profile. It's a single VM, so we are taking the default profile for right now. Similarly, we have shown the VM info, which is like what are the categories attached to it, what is the cluster info which we are deploying our application. Similarly, what is the configuration details, how much CPUs in which image we have used. And similarly, the NIC, which subnet we are going to use, what are the MAC address of it. So these are the details which we have, which we are showing, which are listed down as a VM info, so that we can get more knowledge of what's the IP, because the IP is main. We are showing that into our Terraform output file.
Yep, definitely Abhishek. So I mean that is where how Terraform maintain the state of the single VM applications, right?
Correct.
So Abhishek, shall we look into the second use case?
Yeah.
Right. So you can see is that from the application just now, right? From the blueprint itself, we allow you to manage the life cycle of the VM, such as to start, stop, restart, right, or even to install NGT, right? But for today's purpose, we're going to show you how we can actually use Terraform to stop the VM for this application. Abhishek, over to you, please.
Sure, yeah. Thanks. So when we need to perform an action on the running app, system actions, we can say, so we have to just declare it saying is stop. So now we'll go ahead and see Terraform plan. So yeah, it's saying we have added an action is stop to our running app. So we'll go ahead and do Terraform apply. We'll say yes. And then we can see here as well that our application will go into a stopped state. See, we started the stop application of an running app from the Terraform. With just you need to mention that which action you need to perform on the running app, and that will be able to perform on the application basically.
Wow, that is really cool, man. I'm already excited myself, and it seems to be so easy to use.
Yeah, so we have the application has been stopped, and we can see in the Terraform as well that we have changed the resource from running into a stopped state.
Sure.
So even if we go to the variables, we can see the state of a file that has been stopped. See if we have added an action stop. So the application is in stopped state. See the state of application. It is giving us that is stopped. So yeah, we can
Awesome.
even
Awesome, man. Abhishek, shall we go into the third use case? Because I'm already very excited, right? Because when we talk about application, it is different from infrastructure as a service, right? Such as providing a single VM, right? So over here, you're going to show them how a three-tier application comprises of HA proxy, Apache web servers, and MySQL web servers together with dependencies, right? How this can be integrated easily from the Terraform providers, right? Abhishek, over to you.
Sure, sure. So yeah, we will go through the blueprint, like how our multi-VM application will look like. So this is our multi-VM BP. So we'll see how this BP looks like. Then we will go ahead and perform the running on this particular blueprint. So we have three uh, services added here. One is like HA proxy, where we have filled the details of virtual machines, configurations, disk, NIC, we have added it. Similarly, we have an Apache VM. If you go ahead, we can see we have added the configuration as one CPUs and memory. And similarly, we have a MySQL server, which we are making it try to make a trivial application, how our application will look like. So this is, let's say, our blueprint. Now we are going to launch this blueprint from our Terraform, our multi-VM blueprint. So let's say, so this is, let's say, our blueprint. And now, okay, the one thing I would like to notice here is like runtime meta table. So if we can see, the blueprint has an Apache VM. These contains the details as one CPUs and one cores and memory, right? So what runtime meta tables do, you can change the configuration while you are launching the application. So let's, even your blueprint contains one CPU core, one memory, but at the launch time, you can change this configuration to whatever like you want to have these values. So these runtime is basically those we are saying that, okay, we have one configuration for substrate, basically for the Apache VM, where we are changing this to the, if yes, I'll show you the variables file. So this is a substrate config file where we are just saying our application to launch the BP with particular these details. So I will go ahead and I will show you how we can do it for the application for the blueprint. So we'll go ahead and do Terraform plan. Okay, so it will say that we are going to add one in the resource. And if you can see, we can say in the runtime meta tables, we are now changing the value of Apache VM from number of sockets, CPUs from 1 to 2 and the memory to 2 GB. So we will go ahead and we will say Terraform apply. We will say yes. Now we can jump over to the apps page where we can see the how the multi-VM application is getting provisioned. So yeah, typically it will take again 2 to 3 minutes depending on how we have created a dependency matrix for our application. So yeah, it's here. We are creating a multi-VM application. And again, for creating an app, it will include several steps from packaging install and then making a service restart, a start for every services which we have given. So yeah, we can anyways monitor it in the audit page, where we will see the several steps before creating an application.
But it's actually there is a dependency between that blueprint. All right. So in this blueprint, essentially what is trying to state over here, you see that the white line that was actually pointing from HA to Apache and Apache to MySQL. Right. So what it's trying to say is that as part of this provision of the blueprint, right, MySQL have to be installed successfully first, right, before my Apache can start. And then likewise the same for HA proxy, right? So Abhishek, if it goes back to the audit trail, you will start to see that similar action as well.
Application space, right? Yeah.
Yeah.
So yeah, we can see now the packages are getting installed and how the services are getting created as they are dependent on the top level services. So in the sequence, they will go and create. Yeah, so see, it becomes into running state. We'll see how Terraform will be showing us that our resource got created. Yeah, so see, we have again added a resource. Now, if we go to the services, now we'll see that MySQL has one, and for the Apache VM, we have changed the configuration to 2 cores, 2 CPUs, and 2 GB at the runtime. So we can see how the Terraform can helps to change the configuration at runtime values. and support and change the configuration of a particular VM. Similarly, we'll go ahead and I will walk you through the how our TF state will look like. So let's say this was our multi-VM application. So again, all the actions which an application has will be listed in the actions attribute. The app summary we can see is the multi-VM, the blueprint ID. So we can close this runtime. Now this is the VM app. So we have like 3 VMs. So we'll be seeing the 3 VMs configuration, like what each VM has in it. It has categories, this cluster, we can see the cores, we can see the NIC. Similarly, for the other as well, for the Apache VM, we can see calm name is service. We have 2 cores, we have 2 CPUs. And again, for my actual proxy, we have similarly configuration where we can see the IP of each VM, which we have provisioned right now. So yeah,
Awesome. Right. So this is how Terraform maintain the state, right?
correct,
Mirroring what we see in CAM or NCM Self Service, right?
correct. So
Abhishek, shall we go to the last use case, right? Because I think one of the key thing is about when something was going wrong, right? How do we actually clean out the resource effectively, right? So maybe Abhishek, why not go ahead and show the how we can do it very easily.
yeah, sure. So we can just right now see that we have two in TF state, we have single VM and the multi VM app where we are scraping the state. So we have to do nothing. We can just go into the CLI and we can just say Terraform destroy. And we can come to the outside of this where we can see how our application will get deleted. So yeah, so it will say us that all the resources which we are created is going to get deleted. So we will say yes, we want to delete all the resources, and yep, they will be getting destroying in a state. And if we open any of the, let's say, single VM, we can see the delete operation would have been hit on the application and it will be on deleting state. So yeah, so it's deleting in a deleting state. So yeah, so we can easily delete the resources from the Terraform. We can create it. We can orchestrate all the resources. And if we can see the TF state file, it's become null because we have deleted it from our state file. So yeah, that's all the four use cases we have, Matthew, right now. Yeah.
Hey, thank you so much. I am sure that you guys have a better understanding of how Nutanix can work hand in hand with Terraform providers. So with this, see you guys next time.